Okay, so in this video I want to continue the discussion of this idea of accumulation, and we're going to jump right into an example here. So let's say that we're given that f prime is equal to 2x squared minus 2. We're given an initial condition that f of 0 is equal to 5, and I'd like us to find f of 2. Well, if we think back to how we handled this when we first learned indefinite integration back in 6.1, um, you would see that we would just do something like this. So I'm going to solve it the way we would do it back in section 6.1. So we would just say, well, the antiderivative, if it's f prime, then we just have f. And what is the antiderivative of 2x squared? Well, that would just be simply 2 over 3 x cubed minus the antiderivative of 2 would be 2x, and then we add on this plus c. And then what we would do is we'd say, well, they give us this guy right here. They give us that guy. We know that f of 0 is equal to 5. So if I want to figure out what c is, I would simply just plug in a 0 and then evaluate it and try and solve for c. So then we would say, or we would do, we would do f of 0 equals, let's see, 2/3 0 cubed minus 2 times 0 plus c. We know that all of this is going to equal 5, but then you notice, well, 2 over 3 times 0 to the third, this guy right here is just 0. This guy here is also just 0, so we're left with c equals 5. And so then you'd say, well, we know that our antiderivative function here, we know that f of x here is now going to equal 2/3 x cubed minus 2x plus c, and instead of plus c we can replace c with what we know it is, it's plus 5. So now we found what f of x is. And then finally you'd say, well, look, they want us to find f of 2. So we come back to our problem here. We would come back and you'd say, well, f of 2 is going to equal 2/3, now I'm going to substitute a 2 in here, 2 cubed minus 2 times 2 plus 5, and you would do all the arithmetic. You know, 2 cubed is 8, 8 times 2, 16 over 3 minus 4 plus 5, and you'd end up getting something like 19 over 3. That's how we did it back in 6.1, and what I want to show you here is a different way or a different approach in how to think about this. And one of the things I want to tell you is this, that this is something that you cannot argue with. It's what I call a refutable fact. So what you start, or I'm sorry, how can I say this? What you have now is a function of what you started with plus what you've accumulated since then. So let's just think about what I just said. What you have now is a function of what you started with plus what you've accumulated with. And I could write that simply here, that what we have now is a function of, so I'm just going to say is equals to what I started with plus what I've accumulated since then. So what I've accumulated since then. You might be thinking, well, what in the world does this statement have to do with this problem? Well, if you think about it, you're asked to find f of 2. This is what you're going to have. Now, you will eventually have this once you find it. So we want f of 2. This is what we will have now, or eventually. So we would have f of 2 is equal to, what did you start with? Well, they gave you this initial condition right here. This is what we're starting with. We are starting with f of 0. And then we're going to add whatever we've accumulated. But remember, the integral is an accumulation function. It accumulates net change in area, or area. So what we accumulate is this guy right here. So it's going to be the integral of this guy. So it's going to be the integral from, again, where we started to where we're ending, 0 to 2. And here's our function. 2x squared minus 2 dx. And we can simply evaluate this, and if we evaluate this, we get, let's see here, I'm going to try and squeeze all this in. F of 2 is equal to f of 0. We know what f of 0 is. F of 0 is just given by 5. Plus, and now we have to just anti-differentiate here. So 2x squared, the antiderivative we already know is 2 thirds x cubed minus 2x. But again, by the fundamental theorem of calculus, we know that we're going to have to substitute these limits into this function here. Maybe I should put some brackets here so that you don't include this 5 here. And so what I can do now is clean this up a little bit, and let me just scroll down. Give me some more room here. So I have that f of 2 is going to equal to 5 plus, and now I'm going to go ahead and substitute my upper limit here. So if I substitute a 5, I will have 2 over 3, 5. Oh, why did I put a 5? This should actually be a 2, right? Since my upper limit here is 2, so let me just go ahead and erase this really quick. It was a big mistake waiting to be made. Okay, so we know that this is going to be 2. This should also be 2 cubed minus 2 times 2. And then I have to subtract and plug in the bottom limit. But notice that if I plug in 0, that all this will go away. So to save us some time, I will not plug in the bottom limit because, again, 0 will make all this thing go to 0. So really I'm just going to be subtracting 0 there, which I really don't need to do. Okay, so let's go ahead and clean this up a bit. So we have f of 2 is equal to 5 plus, here I'm just going to rewrite this. I'm going to say it's just 2 thirds 2 to the third power minus 2 times 2. And what does this equal? Well, if you look back here, we had a 5, so there's our 5. If you look back here, we have a 2 thirds 2 to the cube. Here we have a 2 thirds 2 to the cube. 2 to the cube, 2 to the third power, minus 2 times 2, so minus 2 times 2. So it's all there. It's the exact same thing that we had here, and this is equal to 19 over 3. So we get the same answer. So what's the point here? Well, the point is that it's not always going to be very easy to find an antiderivative or to find an antiderivative of this thing and go ahead and, do all this work and get your plus C. Sometimes the problems will be very, very challenging to do, and we'll have to use different techniques to evaluate an integral later on in this course. But you're going to see some calculator questions on your AP exam where it's just impossible to find an antiderivative by hand. They're very, very difficult to find. And so if you know this setup, on the AP exam, you can save yourself a lot of time and a lot of headaches by trying to find an antiderivative for a function, that probably an antiderivative does not exist. So here I'm just starting off with a basic example, but if you can remember this little phrase here, that what you have now is going to be a function of what you started with plus what you've accumulated since then, and set this up mathematically, then you're on your way to solving, an easy calculus problem. Now in the next video we'll do some more examples where the derivative is a lot much more difficult to find, and you'll actually need a calculator to help you out with that, or some type of computer to help you anti-differentiate.